In the last module, the third module of this lecture, we talked about this view that seems to be shared by Perry and his co-authors, as well as Russell, that one of the virtues, one of the values of philosophy is that it causes us to examine our preconceptions, our beliefs, our values, even our very ways of conceptualizing the world, and look at them from alternative perspectives, evaluate them based upon their evidential merit. And that in doing this, it frees us to a certain extent from the default biases that we slip into because of the way in which we evolved, because of the way in which we developed, because of the way in which we were socialized. And we then looked at that video by Dan Ariely that you can watch, and it goes on for much longer on YouTube by following that link that's on the slide. And in that video, Ariely gives us an example of default bias about how just the way a form gets structured can dramatically change the way in which people respond to a particular choice. Now, one of the ways that people oftentimes react to this, and he notes this later in the video, is to find that it's very unintuitive. So they might say something like, well, maybe other people do that, but I certainly don't do that. Or maybe you do that in some situations, but in lots of situations we just don't. That's a very special or weird case. You've just found some bug. But in fact, this isn't a bug. This is a feature about the way in which we solve problems, make inferences, make decisions, and things of that nature. Real decision-making, real inferences in the world, in real time, are incredibly difficult in many, many, many cases. And in order for us to be able to solve problems in real time that are potentially very complex, that are incredibly variable, we need to have certain assumptions that we make. And these assumptions are often called heuristic assumptions. They're called heuristic assumptions because they aren't always true. They are useful. They help us solve the problem. They simplify the problem for us in many cases, but they aren't always true. So one of the ways in which we can get default biases is by having assumptions given to us through genetics, through development, through the way in which we are acculturated. Now, you still may think, well, I don't really think that this is true. So I'm going to give you another example, an example that is very different from the example that Ariely gives us. So here's an example from vision. Now, this picture that you have here is a picture of the St. Louis Gateway Arch. And as you look at it, one of the things you'll notice is that it's taller than it is wide, significantly so. But in fact, it isn't. The St. Louis Gateway Arch is exactly 630 feet tall and exactly 630 feet wide at its widest point. Now, I tell you that, and you still see it as taller than it is wide. And you may doubt that this is true, or you may think that I've altered the picture. So I'm going to give you some more visual cues to illustrate this. So I took a line and I drew it from the top of the arch down to its base, 630 feet. Then I just rotated that line like so. So the St. Louis Arch really is just as wide as it is tall. It is a giant, giant visual illusion. Why do we see it the way that we see it and not the way that it is? Well, we see it the way that we see it because of heuristic, simplifying, but fallible assumptions that are built into the way that our brain processes visual stimulus to determine how far away things are and how big they are, given how far away they are. This is actually a very complicated inferential process, and so our brain needs to make assumptions to help make those inferences in real time. So two of the assumptions that are important for this particular illusion are context. So in determining the size of things, our brain will take context into account. What's around the thing that we're looking at? So when we look at the base, we see a lot of buildings, and that tells us that the base is pretty big. When we look up high here, however, there are no context items. There isn't anything to tell us the relative size of that arch, and so we don't have any cues that will help us determine this. And the context, the things that are around an object that help us to determine its relative size or distance from us, is a very, very important heuristic that we use in vision. So for example, if you ever heard of the moon illusion, the moon illusion is an illusion where when the moon is close, the full moon say, close to the horizon, it looks much larger than it is when it gets higher up in the sky later at night. Now it hasn't changed size, obviously. Why does it look bigger by the horizon than it does up higher in the sky? Because by the horizon, there are all sorts of visual cues that the brain uses to try and decide how big the moon is. When it's high in the sky, there are no cues, and so it doesn't have that information from which it can make a guess of the relative size of the moon. So contextual information was an important feature of this misperception of the St. Louis Gateway Arch. There's another important feature, and that has to do with the geometry of objects. So one of the ways in which our brain decides how far away something is or how big something is, given how far away it is looking at the geometry of the visual scene. So if you were to stand on railroad tracks, and please do not stand on railroad tracks, it's very dangerous. If you were to look down those tracks, it would seem as though they got smaller as they got farther away and they converged off in the distance. Now they don't really do that. However, your brain, whenever it sees converging lines, whenever it sees lines that seem to be parallel get closer together as they move farther away, it makes an assumption that the area where the lines are farther apart is closer to you than the area of the lines where the lines are converging or closer together. And in general, that's a pretty good assumption to make. However, it isn't always true. It isn't always a completely accurate assumption. And so here with the St. Louis Arch, we find our brain doing that. But because it's a building, the base has to be wider than the top of the arch for structural reasons. And because there is this narrowing of the arch as it rises up for structural reasons and not because of how far away it is, it gives rise to this misperception that the top of the arch is much farther away than it would be if the lines were parallel and converging because of how far away they were in the visual scene. So we have these assumptions. These assumptions are assumptions that are largely genetically determined, biologically adjusted to help us make inferences about the size and distance of objects in the visual scene. And those assumptions drive inferences. Oftentimes those are great inferences. Sometimes they're not such good inferences. But we aren't aware that we have those assumptions. We aren't aware that our brain has these sort of beliefs about the visual scene until we start to analyze it, until we start to look at it. And then we can discover the strengths and the weaknesses of the assumptions, when they're successful, when they fail, why it is that we suffer from illusions in certain circumstances. In the next module, we're going to turn our attention from the nature and value of philosophy to the practical advice that Perry and his co-authors give to philosophy students, the sorts of skills that they highlight as important skills for doing philosophy. And then I'll finish off the lecture by suggesting that those skills actually are important for people to have, generally speaking.